Good day, and I welcome you to this class of discussing the application of surds to trigonometrical ratios. Later, we'll be discussing sine and cosine graphs. But in this class, we want to learn how to get the derivation of the sine, cosine, and tangents of angles, especially the basic angles. For instance, if you consider the angles 30 degree and 60 degree, we need to plot or draw an equilateral triangle to derive the sine, cos, and tan of these basic angles. As I said, an equilateral triangle of side 2 units is used to obtain the value of sine, cosine, and tangent of angles in surd form. Okay, look at this triangle ABC. Now, when you say a triangle is equilateral, it means that same triangle is what? Equiangular. A triangle with equal sides, all sides equal, we also have all angles equal. Now, if we have all sides equal to 2 centimeters, then all angles should be equal to what? 60 degrees. Can you see that? Okay, if I divide this triangle into two equal halves by drawing a perpendicular line, a line perpendicular to BC. If I draw a line from A to this point, that line should be straight and perpendicular toward the line BC. That line will divide that triangle into two equal halves, and of course divide this angle here into 30 and 30. So we have this down. The triangle is divided into two by drawing a parallel line. Okay, let's not say parallel line, a straight line from A to BC, a perpendicular line, sorry, not parallel line. Now from A to BC, the resulting triangle is below, so it's drawn below. Look at this triangle. So it has the angle here as 60 degree, the angle here as 30. I got 30 by doing what? By dividing this 16 into two equal halves, and this side should be 2 centimeters. So let's call this length AB. Let's call it X. This length. Okay. Now if I divide this line into, if I divide BC into two equal halves, then I will have here. Okay, for this new triangle, let's call here O, so that you won't be confused. Now, if this is O, if this is actually O, then I'll have this as O. Alright, so now this is triangle AOC, having OC to be what? 1, which is half of 2. Okay, now doing that, this is now a right angle triangle. Therefore, I can use my Pythagoras theorem and Trig ratio to solve it. Now, to get this side x, what do we do? Using Pythagoras theorem, we know that what? Hypotenuse square equals to opposite square plus what? Adjacent square. So I will say 2 square equals to x square plus 1 square. Now, making x square the subject, I will have x square equals 2 square minus 1 square. So that's 4 minus 1, which will give me what? 3. So to get my x, I will say what? Take square root of both sides. So I get x equals to 3. So root 3. So if I replace this my x with root 3, what will I have? I will have the sides of this triangle AOC being equal to what? 1, 2, and root 3. So very simple. If I'm asked, now what is sine 30? So for angle 30 degree, what is the sine, what is the cos, and what is the tan of 30 degree? You can also get this using your calculator to confirm if you are correct. So after this class, try to punch sine 30 on your calculator. You should get 2.5, which is half. Now let's check if it's true. Considering angle 30 here, what is sine? Sine is what? Opposite over what? Hypotenuse. So we say what? 1 over 2. Bravo. So we get half. So if you press your calculator, you should get sine 30 equals to half. So this is a faster approach, and an approach that expresses your angles in surdic form instead of decimal form that the calculator will give to you. If you also punch cos 30 in your calculator, you should get an answer 0.866. Now, but in this case here, cos 30 should give us what? What is car? Adjacent over what? Hypotenuse. So cos 30 is what? Adjacent, which is x. Of course, x is what? Root 3. Root 3 over what? Hypotenuse. 2. So we get root 3 over 2. Can you see that? Very simple. Now, what is tan 30? Tan 30 should give us what? Tan is what? 2. Opposite over adjacent. 1 over root 3. And that's this. So you can say you don't want it to be in this form. You can rationalize. That will give us 1 over root 3 times root 3 over root 3. So you have what? Root 3 over what? Root 2 times 1, root 3 times root 3 give us 3. So you get root 3 over 3. That is tan 30. Or you leave it in terms of 1 over what? Root 3. Therefore, if I ask to find tan, sine, or cos of angle 30 degree in short form, you can do it. All you need to do is to draw. If you draw an equilateral triangle, divide it into 2 equal halves, then have your angles 30, 60, and you have 1, 2 here. Find that line AO, which is what? Root 3. Then you do what we just did just now. That's simple, I think. Okay, let's move to angle 60 degree. Considering triangle AOC, this same triangle. So we say what? Sine 60. You give me what? This is 60 here. Opposite of hypotenuse. This is the angle that's opposite to this angle. So it's opposite root 3 over hypotenuse. Root 3 over 2. You can see it. So what is cos 60? Cos 60 is what? Adjacent over hypotenuse. To this angle, this is adjacent, this is hypotenuse. So you have 1 over 2. Of course, you expect cos 60 to be equal to sin 30. Why? Because they are what? Angle 60, 30 gives what? They are what? Complementary angles. Do you understand? Alright, so let's talk about tan 60. What do we have? Tan 60 is what? 2 opposite over what? Adjacent. So root 3 over 1, which is root 3. Very simple. Root 3 over 1. 2. You get root 3. Alright, so now, but if you ask to do that of angle 45 degree, what do we do? What you need to do first is you don't need to draw an equilateral triangle here. What we draw here is a right angled isosceles triangle. What do I mean by a right angled isosceles triangle? An isosceles triangle is any triangle that has two sides equal and the third side not equal to the other two, but the base angles of that third side are equal. What am I saying? Draw a triangle that is right angled, having sides 1, 1. Then the hypotenuse we don't know, but because we have 1, 1, the angles here should be equal to what? 45, 45. Why? If you add 45 plus 45 plus 90, we get 180 degrees. Don't forget. So you draw an equilateral triangle that is right. Sorry, you draw an isosceles triangle that is right angled. So now we have to calculate this hypotenuse. What do? We know that what? Hypotenuse square equals to opposite square plus adjacent square. So we say m square equals to 1 square plus 1 square, and m square gives us 1 plus 1, that is 2. So m equals to what? Root 2. So you just replace m here with root 2. Now, very simple. So we are asked to find cos 45. You are free to pick any of the angles. They are actually the same thing. So if you say cos 45, okay, let's have a sine. Sine 45, you should get what? Sine opposite over hypotenuse. If you are picking it 45, opposite over hypotenuse, that is what? 1 over root 2. Okay, and you can also rationalize because you have root or surd in the denominator. So we'll say what? 1 over root 2 times root 2 over root 2, and that will give us what? Root 2 over 2. So your answer of 75 should be either 1 over root 2 or root 2 over 2 when rationalized. Alright, so if you say you're going to find cos 45, what do we do? Cos 45 should give us what? Cos adjacent over hypotenuse 1 over root 2. Same thing. Of course, you expect the same because 45 gives 90. They complement themselves. Of course, the answer should be equal when you find the sine and cos of these two angles. Of course, they are the same. Alright, so tan 45, tan should give us what? 2. Opposite over adjacent. And what is the opposite to 45? 1. Adjacent is 1. So you have 1 over 1 to be 1. So now if you punch tan 45 in your calculator, you should get 1. Do you understand? Alright, knowing this, we can apply this to solving some problems. Example 1 says, calculate the lengths marked x, y, and z and give your answer in short form. Sorry, it should be an answer here. Give your answer in short form. Okay, so this is the problem. We are given this triangle ABCD. We are asked to find the lengths x, y, and z. So what is z? Is AB, x is AC, and y is AD. Okay, very simple. Considering any of them first. Now, to find x, what do we do? Look at this. We have the angle given here, and we have this, and we have this. Can you see that? It is easy or easier for us to find x. To find x, what do you do? Look at this. This x is opposite to angle 60 degree, and we have 3 being adjacent to what 60 degree. So let's look at something as opposite and adjacent, that is tan. So tan 60 is what? Tan 60 is opposite over adjacent, that's what? X over 3 tan 60. But now the issue is, what is tan 60? Don't forget, we are asked to what? Leave our answer in surd form, so you cannot use your calculator here. You must use what I just taught you now. Now tan 60 is what? So you quickly draw your triangle for tan 60, for 60, and you check what's tan 60, root 3. Very simple. So you come drop root 3 here. Therefore, if tan 60 is root 3, then you can find x. If you multiply, you have x equal to what? 3 times root 3, and we have x equals 3 root 3 centimeter. Very simple. Now that we've known x, you can find z and you can find y. Okay, in triangle ABC, in triangle ABC, can you see that triangle? So let's find z. How do we find z? For z, we have 60 degree here, we have 3, we don't know z. We can use, so what can we use? What Trig is combining to 60? What is z? Z is what? Hypotenuse. And what is BC? That's what? Adjacent. So what Trig is combining that opposite of, okay, we may also use, because we have x, we can also use sine. Yeah, so we say what? Also we can use cos as well, because we have z, and because we have 3 and we have this. So if you want to use cos, we say what? What's cos 60? Car, adjacent over hypotenuse. So we say cos 60 is what? 3 over z. Cos 60 is 3 over z. So what is cos 60? Equals to sin 30, that is half. 1 over 2 equals to 3 over z. So you go draw your triangle if you don't know it, or yes, you draw a triangle, but then you should know that cos 60 equals sin 30 equals to half. Okay, so when we put our half for cos 60, we can find z by multiplying. So if you do that, we have z times 1 equals z, and of course we have equal to what? 2 times 2, 6. So z is 6 centimeter. The last is to what? To find y. Okay, so how do we find y? Look at this. Don't forget that we already have x, because we can find y. We can use this angle here. Now what Trig is combining? X and y. What Trig ratio? To 30, x is what? Opposite. This is hypotenuse. So sin 30 is what? Opposite over hypotenuse. And what is our x? Don't forget, we got our x to be what? 3 root 3. So we say sin 30 is 3 root 3 over y. Very simple. Sin 30 is 3 root 3 over y, and sin 30 is half. Half equals 3 root 3 over y. If you multiply, you have y times 1 equals y. 2 times 3 root 3. 2 times 3 is 6. That's 6 root 3 centimeter. And your answer is left in surd form. I believe that's clear. So you have this evaluation to solve. Now, in our next class, we'll be discussing the graphs of sine and cosine of angles between 0 and 360 degrees. I hope the class is clear. So do your evaluation. Thank you.